Alright, this lesson is on adding and subtracting radicals. The square root of 3 times the square root of 7 is the square root of 21. You just multiply the two numbers together. However, addition of radicals does not work the same way. The square root of 3 plus the square root of 7 is not the square root of 10. No, does not work that way. This is the way it works. Add or subtract. It's like adding like terms. If we have the square root of 5 plus the square root of 5, that means I have two square root 5s. In other words, 1 square root 5 plus 1 square root 5 is 2 square root 5s. 7 square root 3s plus 2 square root 3s gives me 9 square root 3s. If I have 5 square root 2s minus a square root 2, then that means I have 4 square root 2. So to add or subtract radicals, they have to be the same radical. In other words, like terms. The square root of 44 plus the square root of 11. Now, the way that this is right now, I can't add them together. However, if I simplify the radicals first, I may be able to combine them as like terms. 44 is 4 times 11. So we're adding here. Let's fix that. 4 times 11. The square root of 4 is 2. So square root 44 is 2 square root 11 plus square root 11. I've both written them as like terms. They're both square root 11s, and so now I can add them together. I've got 2 square root 11s plus 1 square root 11. That will give me 3 square root 11, and I've added them. Okay, so once again, you can only add or subtract radicals if the radical, what is under the radical itself, is identical. 3 square root 24 plus square root 54. Okay, so first I'm going to simplify the radicals. Let's see, 24 is 4 times 6, and 54 is 9 times 6. The square root of 4 is 2. So this is now 3 times 2 square root 6 plus the square root of 9 is 3. So this is 3 square root 6. Let's multiply these two numbers together. 6 square root 6 plus 3 square root 6, which is a grand total of 9 square root 6. And we've added the radicals together. Let's look at another one. 2 square root 20x minus square root 45x. Okay, simplifying. 2 square root 20 is 4 times 5. 45 is 9 times 5. The square root of 4 is 2. So I have 2 times 2 square root 5x is left under the radical. The square root of 9 is 3. So this is 3 square root 5x. 4 square root 5x minus 3 square root 5x leaves us with 1 square root 5x. Here's another one. 3 square root 8 minus 6 square root 50 plus 2 square root 200. All right, we're going to simplify each radical first. 8 is 4 times 2 The square root of 4 is 2, so this is going to be 3 times 2 square root 2. Let's go to the next one now. Minus 6 times 50 is 25 times 2. The square root of 25 is 5, so this becomes 6 times 5 square root 2. Next one, plus 2 times 200 is 100 times 2. The square root of 100 is 10, so 2 times 10 square root 2. 6 square root 2 minus 30 square root 2 plus 20 square root 2. If we add all that up, that's going to give us negative 4 square root 2's. Now keep in mind that something like this, square root 5 plus square root 10, I can't simplify square root 5. 10 is 2 times 5, but there's no perfect square in there. I can't simplify that either. And so these radicals cannot be added together. In other words, we cannot simplify something like this. And so there are some radicals that we cannot add together. Let's look at a cube root now. We got 7 cube root 16. Oh, I'm sorry, that's wrong. No, that is right. 7 cube root 16 minus 5 cube root 54. Okay, we got to find perfect cubes. A perfect cube in 16 is 8. 8 times 2 is 16. And we have a perfect cube of 27 in 54. 54 is 27 times 2. The cube root of 8 is 2. So this is 7 times 2 cube root 2. Minus 5 times. The cube root of 27 is 3. So this is times 3 cube root 2. This is 14 cube root 2's minus 15 cube root 2. 14 minus 15 is negative 1, so this is negative cube root 2. Negative 1 cube root 2. Cube root of p to the 4th, q to the 7th, minus cube root 64 pq. Okay. Let's use our shortcut here. 4 divided by 3, or in other words, 3 goes into 4 once. So that means I got p to the 1st on the outside with the remainder of 1. So that means a p to the 1st will be left inside. Remainder in there. 3 goes into 7 2 times. So that means I'm going to have a q squared on the outside with a remainder of 1, and so there's a q to the 1st inside. Minus the cube root of 64, that's a perfect cube, that's 4. So this is 4 cube root pq. So in other words, we got pq squared cube root pq minus 4 cube root pq. Now since the radicals are identical, a cube root pq, these are considered like terms, and so we can write this as pq squared minus 4 pq squared minus 4 cube root pq's. In other words, it's sort of like factoring out the cube root, and that's our result. Let's look at another one like that. 2 cube root x squared y plus cube root 8x to the 5th y to the 4th. Now this first one, there's no perfect cubes under the radical here, so I can't simplify that radical, but the next one I can. The cube root of 8 is 2. And now I'm going to use my shortcut. 3 goes into 5 one time, so that means there's an x to the first power on the outside, with a remainder of 2, so I got x squared left inside. 3 goes into 4 one time, and with the remainder of 1, so there'll be a y to the first left inside the cube root. Okay, so we've got 2 cube root x squared y plus 2xy cube root x squared y. If we factor the cube root x squared y out, we are left with, in the parentheses, 2 plus 2xy. 2 plus 2xy. Cube root x squared y's. And this is our answer. One or two more examples. Let's look at this one now. The square root of 80 over y to the 4th plus the square root of 81 over y to the 10th. What I'm going to do first is use my quotient rule. This is the square root of 80 over the square root of y to the 4th. This is the square root of 81 over the square root of y to the 10th. Let's see if we can simplify the square root of 80. 80 is, we need a perfect square, so 80 is 16 times 5. Over y, the square root of y to the 4th is just a y squared, plus the square root of 81 is 9, and the square root of y to the 10th, 2 goes into 10 exactly 5 times as y to the 5th. Now the square root of 16 is 4, so we have 4 square root 5 over y squared plus 9 over y to the 5th. I want to add those two fractions together, so I need a common denominator, which would be y to the 5th. So I need to multiply this fraction here by a y cubed over a y cubed. And if I do that, I will have now on the denominator y to the 5th, and in the numerator I've got 4y cubed square root 5 plus 9. Let's fix that. 4y cubed square root 5 plus 9 over y to the 5th. There we go. One more. 2 square root 75 over 16 plus 4 times square root, that's smaller square root 8 over square root 32. Okay. I'm going to use my quotient rule again. This is 2 times the square root of 75 over the square root of 16 plus 4 times. Now in this one I'm going to use the quotient rule backwards because I know that I can reduce the 8 and 32. This is the square root of 8 over 32. 2 times the square root of 75 is the square root of 25 times 3. The square root of 16 we know is just 4. Over here this is 4 times the square root of 8 over 32 reduces to 1/4. Let's do some reducing now. 2 over 4 reduces to 1/2. In other words, 2 goes into 4 twice. And right here I've got square root 25 is 5. So this becomes 5 square root 3 all over 2. Over here we got 4 times the square root of 1/4 is 1/2. And so this becomes 5 square root 3 over 2 plus 4 over 2. Put that together in one fraction and we got 5 square root 3 plus 4 over 2. And that is our result. And that is all there is to adding and subtracting radicals.